Sorry. Oh. Okay, well, I guess there's been 15 minutes of me talking when no one can hear me. Yep, my OBS settings were not correct. Oops. Man, me trying to do stuff on this final spiral staircase is just feels like a comedy of errors. Okay, I'm going to just quickly repeat what we're doing. Because, yep, my mic was not streaming to YouTube. We're going to, so what we're doing is each of these points is going to, or as the player walks around the spiral staircase, I want the sound of Barbalith to change, basically. So we're going to use these points as kind of proximity sensors. So as the player gets closer and further away from each of these points, we're going to hear the sound basically blend in and out. And that's it. That's what we're doing. So what I've done is I've added a, turn the sound on. So I've added an extra node 1 element to our Barbalith patch. Sounds like this. So we're going to hear this blend in and out as we walk around the spiral staircase. And then I've created this script that's basically going to send the player's distance to each point. It's going to send that as a named signal into the PD patch. So the first point is going to send the node 1 signal. And we're going to keep doing that. So, okay. Let's see. So I'm going to start with this point. And our radius is 1, which is way too small because you can see. I'm going to need to make that bigger. Let's see what it looks like when I've got it set to 10. 10 is quite nice, but I think I probably want these to overlap, so let's make this a bit bigger. 14? Nope. Let's try that. Okay, let's try that. So, and then we're going to need our Barbalith libpd instance. It's going to be called node 1. Did I capitalize nodes? No, I didn't. Okay. And we're going to need our player transform. Okay, so what I'm hoping will happen is that when we spawn into this this final scene, we'll be able to hear that sine tone blend in and out as we get closer and further away to this point. Okay, is this us? Oh, wait. Hang on. Something's not working. Oh. Oh, is that why we're not hearing anything? Let me just check. So first of all, I went to all this trouble to make sure that my binding and unbinding was safe. I didn't do the same thing in update. Let's just quickly fix that. So we're only going to update stuff if we have an actual PD patch to send to. Let's try that again. I think I should have still been able to hear that sine tone, but I don't know. I don't know why it jumps at that point. So, out here we should be more or less on top of it, but I'm not hearing any sine tone. Why? Okay, so why could we not hear anything there? Receive node 1. So on start, we bind to our signal, node 1. Okay, well, I guess we're just going to send a whole bunch of debug logs to see if we can figure out why it's not working. Okay, so let's say signal. So this should show us what we're sending to the PD patch. And it will tell us if we're not sending it for some reason. Okay, so we're definitely sending a signal to PD patch. Wait. Why are we sending 0 to the PD patch? Oh, okay. Now we're sending almost 1, but we're not getting it. Okay. So let's see. Let's just kill the drone so we only hear so that we only hear the we'll only hear the sine tone, and then I'm also going to print the value that we're sending from PD so that we see what PD thinks is happening. Oh, so, yeah. So I guess when we're this side, we shouldn't be sending anything because we're outside of the sphere. Oh no, there it is. Oh, is it just too quiet? Oh, wait. I think it's too quiet. I think the problem is I've been testing it against the original Barbalith sound, which is basically this bit. But by the end, we have Jan's big synth, which I think boosts the volume quite significantly. So how is it doing that? I kind of need to know how Jan is boosting the volume so that I can also boost my volume accordingly. Or do I? No, maybe I don't, because by the time we reach the end, it's at a fixed size, right? So we can actually just assume. Well, first of all, I can get rid of that. We can actually just assume that this should just be louder. So if I do this, that's a bit redundant, but we'll leave it in there for now in case I need to boost it further. If I do that, then hopefully we'll be able to hear the sine tone over the sound of the enormous synth now. That's what I'm hoping. It's a bit quiet against Jan's drone. Oh, so what am I sending? So I'm sending 1 to 20. Then I guess 0 to 19. Divide by 4. Sorry, I'm trying to work out our overall levels. Because I feel like I need to boost the volume of this, but then are we not going to be clipping when I do that? I'm a bit uncertain about what's going on with the levels in all of this. But okay, we'll try this. See if that makes the sine wave the sine tone a bit more prominent. And then we might fiddle with some other things. Not not super prominent. I think also the radius could be bigger. So I think what's happening is our big synth is so loud that we're actually clipping and we're eating up all the dynamic range, and the sine wave's kind of getting lost in that, maybe? I'm not sure. I'm a wee bit confused about how this patch is working now, to be honest. But yeah, one last test, and then I'll probably leave it at this and move on, and we can fix the rest of it later. I just want to check that this sounds okay with the larger radius and the louder sine tone. Now that I think about it, this spiral staircase is a 3D object, right? Maybe I don't actually want my sphere. Maybe I actually don't want to test the distance to the sphere in 3D. Maybe I want to treat this as a cylinder so that we only detect the player's distance on the XZ plane. That would probably make more sense, right? So that way we're getting the same effect if we're at the top of the spiral staircase as if we're at the bottom. At the moment, we get it loudest at this very specific point in space, and once we get up to the top, it's going to be quieter. But I think actually that's not what I want. So let's come back to my script, and what's the easiest way to do this? I guess I just do new vector 3. Ignore the y-axis. Player pause dot position dot z. So we're basically creating a new version of the vectors here, which both have the exact same y-axis position, regardless of where the player is in the space. I think this is what I want to do. In fact, sorry, let me just check. Does Unity have a draw? Oh. Does Unity have a gizmos.draw cylinder? So we can... Oh, no. Oh, that's a shame. Okay, well, we're going to have to draw it as a sphere in the editor, which isn't ideal, but it'll do. At least we can see it. And in fact, if I switch to... Can I switch to... Can I switch to orthographic? Wait, can I not? Oh, oh, whoops. Ah, there we go. No. Oh, come on. Oh, actually, no, that does work. It's just, oh, pan. Oh, okay. Never mind. I got myself confused there. Okay, sorry. I should stop playing about with the editor, trying to get it to look the way I want. So now, regardless of where I am on the y-axis, I will hear the same level of this particular sine tone, which is probably going to be useful. Definitely sounds like it's hitting the headroom, or hitting the upper rim limits of the... What's it? Okay, there we go. Now I think one thing I do think I need to do is, at the moment, what's it doing? So at the moment we're kind of treating distance as a linear variable, but it would probably be better if we treated it as a logarithmic variable. I just need to... I'm going to leave that for another time because I can't actually remember the maths that I need to treat this as a logarithmic variable. So we're just going to ignore that for now, because it probably makes more sense for me to move on to the next element of the sound. I wonder if I'll get all four in by the end of the stream. So we have this sine tone, which I think works quite well. Now, what else could I do? One thing that might be nice is to add in a comb filter effect. I think what I'm going to do this as a PD comb filter. We'll do that. So a comb filter, if you're not familiar with it, is basically... It's you can think of it as a digital delay with a very, very short delay time. And when you have a delay with a very short delay time and you turn up the feedback, this has the effect of basically introducing this kind of metallic resonance into the signal. Del. And we don't need a very long delay. Let's go with that. Let's go with that, just in case. Nope. Oh, what have I done wrong? Oh. There. So we're gonna write into our delay line, and then we're gonna need to read from we're going to need to read from our delay line, and now I guess what would be interesting here is if we use our frequency that we're generating for the comb, the bass drone of the filter of the sound. If we use the frequency of that to set our delay time, so that our comb filter is basically resonating in sympathy with our drone. That could be fun, right? So let me just check how del read works. Oh, I did not want you to turn on DSP, thank you. So, okay. Can we... Can we send in, does it have to be a control value? I guess it has to be a control value. That's a bit frustrating. Oh, what's del read 4? Oh, del read 4 would make more sense. That's what I'm looking for. So del read 4. And then we're going to send in, so our first inlet is going to be the audio inlet, and then we're going to have a second inlet that is going to set the delay time. And then let's see, so we're going to also want, we're going to want some feedback to our signal. So I'm going to try this, and I'm going to see what this sounds like. And write the output of our delay, of our comb filter basically, back into the input of our delay. And then we're going to need our outlet, where we're basically just going to write our input, or we're going to write the output of our comb filter onto the, on top of the input, because that's what gets that really nice metallic sound. And let's see, so we're going to be feeding in the frequency of the drone. So what I probably actually want to do is I want to convert from the frequency back into the number of milliseconds that that frequency corresponds to. So what would that be? Oh, well, it'd be just one, just be 1 over. Oh, hang on. What am I doing here? So it would be 1 over our 1 over our frequency will give us the number of seconds that corresponds to the period of our signal. Del read operates in milliseconds though, so we then need to multiply this by 1000. That'll give us the number of milliseconds. Now I guess the one thing I'm not certain about, does signal store, stop doing that. Oh, does signal store its value? Yeah, I guess it does, right? I think it probably does. Okay, so if I just add in, sorry, let me just, if I add in a load bang here, and I should probably add some comments to explain what is happening. So this is our audio in. This is our resonant frequency. Okay. Okay, now let's see. Oh. Yeah, and again, kind of. Oh, I really hate that PD does that. In fact, I'm going to create a nothing object just so that I can get some more space on this patch. There we go. Okay, right. Let's see. You come down here. We're going to delete the right channel. We're going to just focus on the left channel for the time being. And then my frequency is up here. That needs to come down here. Oh, this patch is getting to be such a mess. Anyway. And actually, before I do this, I just want to blast my ears out with this. So we're going to add in a safety slider. Okay. Huh. Okay, so that's interesting. That's not quite what I was expecting. What if we multiply our frequency by 4 to get a higher pitch. So that did not seem to change anything to me. Oh, of course I needed to do that to update the signal. Interesting. So I think this could work. I guess what I want to do now... Oh, in fact, hang on, what happens if I turn up the... Ah, okay, so this gives us a kind of cleaner kind of signal. So I guess what I want to do now is I want to have a kind of mix parameter, so I blend between... In fact, actually, this is probably quite straightforward now that I think about it, because probably all I need to do here is add in a multiplication where we're going to multiply our comb... Nope. Oh no, I guess that's right. And multiply our comb filter by node 2. Okay, and save. Now let's see, and I guess delete this because it was actually working okay. I guess, the fact that this patch is stereo makes this so much more complicated than it needs to be. Trying to think the best way to do this. Well, I guess I can just copy and paste, can't I? That's probably the simplest solution. I guess I need to rename the delay line. Otherwise everything will be the same, so that's fine. Yeah, okay, and we're going to save. And okay, oh, actually, hang on, I should rename these. Then you can be node 2. And yep, so what did I say? Let's see, so 16 for the radius. Barbalith is our libpd instance. This is node 2, and then player is there. So okay, so we should get an overlap between these two, which should be fun. And yeah, let's see what this actually sounds like. It might sound I don't know what it's going to sound like when we're hearing like the full level of the big synth. Definitely need to fix that bit. There is some weirdness. There's definitely some weirdness here. But I guess I'm gonna leave it for now. Yeah, and we'll just keep going. Actually, hang on. Let me just So what I'm a bit curious about is what happens if we, instead of taking our resonant frequency from the patch where we have this kind of varying frequency, what if we just set a constant frequency? How does that change the sound? Let's just see. Oh, actually, hang on. If I just, what would this? Oh, what would this be? This would be, oh, well, I think it's 50, right? I think that's what I said. Oh. I really wish sliders just came in a 0 to 1 range by default. That's incredibly frustrating. So actually, it doesn't make a significant difference. So just leave it as it is. Okay. Okay, right. So that's my comb filters. I guess So I've got node 1, I've got node 2, and I guess I want sounds that kind of vary nicely. Oh, put that back in. So I wonder what the next thing should be. I guess I think I'm probably going to manage 3 nodes today because we're getting close to the end of our hour. I guess one thing that might be nice is to have some really kind of tight peaking filters. Again, this patch is kind of a mess. Okay, let's try moving some of this stuff up a bit. And then we have this. And then we have this. Yeah. So how would I do this in a way that made sense? Would will a bandpass filter on its own have a tight enough Q to actually for it to be noticeable? Oh, actually, sorry. What are the center frequency and Q? So if we initialize this to center frequency of, let's go with 16. Wait, no, hang on. So again, like our root frequency is around about 50 hertz, around about because we've got our noise kind of, yeah, we're kind of starting at 50 hertz and we're kind of varying around 50 hertz. So this will probably work best if we set our center frequency of our peaking filter or our bandpass filter to be a multiple of 50. So we've got what, 50, 100, 200, 400, 800. If we go with 1600, that's probably going to be fairly high, which is probably, that's probably quite nice, high value. And then, now let me see. Is this going to work the way I want it to work? Like if I could set Q to 0, does that mean that it basically lets through all the sound. Let's find out. Wait. Wait, why are we hearing the comb filter there? Oh, I might need to do this just to reset it. I mean, that is an interesting effect. It's not what I was looking for. Okay, I guess I probably need to do another sub patch. So I guess this will be called. I'll just call it peaking. So okay, so we're gonna have our audio input. We're gonna have our bandpass filter at 1600 hertz. And I guess I want, in fact, why don't we just set this as a really high, try that as a kind of, as a Q value. And then we will just blend between the filtered value and the original input value. So I guess if I have receive node 3, move this over a bit. So when node 3 is 1, we want our bandpass filter to be 1. So that's straightforward. And then we want to invert that, which we can do with expr 1 minus, let's see, what is it, f1? Is that right? Never remember how expr works. f1. So we invert this signal and use it to multiply the default input signal. Okay. And if we come back here and connect this up, so we should hear just the original drone now. Or we could hear nothing. That is also an option, apparently. Let's see. I mean, do I need to pass in 0 to both of these? Yeah, there we go. Okay. Well, first of all, that is not good enough. Secondly, I think we can make this higher. I make this 24. Actually, make this. Okay, we're going to have a really high Q, and I'm going to need to multiply that quite a lot so that we can actually hear it. Try this. That's better. Okay, let's try that. And copy paste. We'll do the same thing, and I guess that might be it for today. This patch has gotten way too complicated. Yeah, okay, we'll do that, and then if I set this to node 3, in fact, just rename all of these while I'm at it. So, let's see, what did I say? Did I say 16? Yeah. And then Barbalith, node 3, and player. Yeah. Oh no, I've broken it somehow. this this final section feels like so many bad things are happening to the audio, and it's not necessarily a bad thing that's happening, but yeah. Okay, well, I think what was happening there, the reason we couldn't hear it first off was because I need to initialize this. So we'll initialize it to 0 and just pass that in here. Oh, and I guess I need to do the same thing to the copy because I just did these as basic. Subpatches. Is that right on both of these? Okay. So that should ensure we hear them all straight away. Yeah. I guess I can move this up. Let's just delete that. Yep. Okay. I think I'm probably going to, let's just quickly run back through it again, just to make sure that that change fixed it, not making sound to begin with. To fix that. So actually, I'm wondering, since it's already distorting, let me just check. I'm wondering if it might be worth just quickly I wonder if it might be just worth just quickly adding in a very simple soft clipper to the output of this. Let me just remind myself again how expert works. So do I just do $V $V1? Maybe I do. Maybe that's all I need. Let's find out. Is that valid? And then, oh, once again, run out of space. Okay, that seems like it works. So, okay. So if you're not familiar with using tanth in this function, in this in this manner. Tant is a really nice function if you want a nice kind of smooth distortion. So not the kind of hard clipping digital distortion. Tant will give you a soft clipping. So let's see how this changes the sound now. It might change it quite dramatically depending on how loud our output signal is. Whoa. Okay. That very clearly does not work. I'm going to have to delete that. That does suggest that our audio is going way outside the limits of the system, which is kind of bad. We're gonna have, well, too late to fix that today. That's a problem for future, Neil. But yeah, so we didn't quite finish this spiral staircase, and we're gonna have to do a lot of work on Barbalith to get it to not be hideously distorted. If that's what we want. Maybe we want it to be hideously distorted. But yeah, we made a start on this, and the basic functionality is there, so great. Okay, I think I'm going to leave you there. So thanks for watching. Apologies again that we had 15 minutes of silence at the start. Hopefully, my next stream, which might be my final stream, will be less less of a disaster. But yeah, thanks again for watching. Jan will be back next week. Yeah, I guess I'll see you in a couple of weeks. Bye.